Okay, so since salts have different KSPs, you can have a solution containing ions of salts that you want to precipitate out. But let's say you have an experiment in which you want to keep one salt dissolved in solution while the other crashes out of solution as a precipitate. Then you have selective precipitation. And that takes advantage again of the difference in KSP values of the salts. Now, when selective precipitation is usually used for qualitative analysis of ions, there is a good amount of reading material in your textbook about qualitative analysis, but we're not going to go over them for this course. Instead, we're going to work on this problem instead. For this problem, you want to separate out silver ions from lead ions. And here, you have a solution containing ions of both. And you can precipitate both silver chloride and lead chloride if you add sodium chloride. That is, the chlorine or chloride from sodium chloride will react with silver and lead. And you're asked here what concentration of sodium chloride is necessary to begin the precipitation of each salt and which salt precipitates first. Okay, so again, the only component in sodium chloride which actually is participating in the precipitation of either silver chloride and lead chloride will be the chloride ions. Okay, so if we can actually calculate those chloride ions, then we can determine what the concentration of sodium chloride is. I mean, they're equal to each other basically. So this problem is very similar to what we have done before when we were calculating for the minimum concentration of barium ions given an amount of carbonate ions in solution. Okay, so for this one, let's begin first with silver chloride. Okay, so remember that what we did before was to write an ice table. So that should be molarity and then silver chloride in equilibrium with silver plus and chlorine ions in solution. Okay, that should be ICE. Okay, and we will write here a concentration for silver, 0.010. That's how much we have at the very beginning. And then we have no chloride ions. Okay, this is plus S. This is plus S as well. And this one will be 0.010 plus S. And then this will be S. And we can just assume that this is 0.010 at equilibrium. Okay, so we can calculate here what the value of S is, which should give us the chloride ions concentration. So that should be set up an expression for KSP 1.8 times 10 to the negative 10 is equal to 0.010 times S. Okay, and you will calculate here that S is equal to the chloride ion concentration again, and that's equal to 1.8 times 10 to the negative 8 molar. Okay, so this just means that a little bit over 1.8 times 10 to the negative 10, meaning again a little bit over it, will cause the precipitation of silver chloride in solution. Okay, so that's a tiny amount, by the way. And then we go to lead chloride, do the same thing. Okay, we write a nice table. So that will be PbCl2, Pb2 plus Cl minus. But of course, don't forget to balance the equation. Okay. Now here we have an initial concentration of lead 2 plus, that's 0.020. Okay. And then we begin with no of chloride ions. This will be plus S. Now this will be plus 2S. Okay. And this will be 0.020 plus S. And this will be 2S at equilibrium. Okay. So again, we can assume that this is just 0.020. Okay. And we just need to solve for 2S. Okay, now again we're solving here for 2S. I mean, you can solve for S, sure, but 2S actually gives us the concentration of chloride ions. So once we actually get 2S, we can just stop. Okay, so that will be 1.7 times 10 to the negative 5. That's the KSP value for lead 2 chloride is equal to 0.020 times 2s squared. Okay, if we simplify this, we get 2s, okay, is equal to 2s squared is equal to 1.7 times 10 to the negative 5 divided by 0.020. Okay, and if we get the square root of both sides, we are going to get 2s is equal to square root of 8.5 times 10 to the negative 4, and therefore the value of 2s, which is the value of chloride ions, should be 0.029 molar. Okay, so notice that this value of Cl minus that's needed to precipitate out lead chloride is much bigger than this value of chloride ions needed to precipitate out silver chloride. Okay, so therefore here silver chloride should precipitate first. Okay, since less amount of chloride ions are needed than for Pb2+. Okay.